morning. We are going to study about the power cycles of all single digit numbers. Okay, let us start with 1. 1 raised to any power is 1. So the last digit of 1 raised to any power. Now let's look at 2. 2 raised to the power of 1 is 2. 2 raised to the power of 2 is 4. 2 raised to the power of 3 is 8. 2 raised to the power of 4 is 16. The last digit of which is 6. Now, when we multiply 2 again with 6, we get 12. So the last digit of 2 to the power of 5 is 2. 2 to the power of 6 involves multiplying 32, which is 2 to the power of 5, 32 with 2 again, which is 64. 2 to the power of 6 is 64 and it ends with 4. So the last digit of 2 to the power of 6 is 4 again. Now the last digit of 2 to the power of 7 will be 64 into 2. It ends with 8, 128. 2 to the power of 8 is 2 to the power of 7 is 128 and hence the last digit of 2 to the power of 7 is 8. 2 to the power of 8 is 256. The last digit is 6. Now we can understand the pattern for this, that the power cycle of 2 is 2, 4, 8, 6. 2, 4, 8, 6. Just a second. The power cycle of 2 is 2, 4, 8, 6. To solve any problem like the last digit of 2 to the power of 394, express 394 in the form 4n plus k based on this by dividing the number above 2 by 4 and finding the remainder. The remainder will be k. If the question is asked to find the last digit of 2 to the power of any number, we can solve it by expressing it as 4n plus k and knowing that 4n plus 1, if the remainder is 1, the last digit is 2. If the remainder is 2, the last digit is 4. If the remainder is 3, the last digit is 8. And if there is no remainder, the last digit is 6. So, the power cycle of 2 is 2, 4, 8, 6. Let us look at power cycle of 3. 3 raised to the power of 1 is 3. 3 raised to the power of 2 is 9, which ends with 9. 3 raised to the power of 3 is 27, which ends with 7. And 3 raised to the power of 4 is 81, which ends with 1. 3971 is a power cycle of 3. Now, we know that if we multiply 1 with 3, that is, if we try to find 3 to the power of 5, we need to multiply 81 into 3, which is 243, and it will end with 3. 3971 is power cycle of 3, and it repeats itself every 4 hours. The length of the power cycle of 3 is 4. Now, let us look at the power cycle of 4. Power cycle of 4 is 4, 6, 4, 6. The length of the power cycle of 4 is just 2 and 4, 6 is the power cycle. So, if 4 is raised to an odd number, the last digit will be 4, and if 4 is raised to an even number, the last digit will be 6. Now let us look at 5. For 5, the power cycle is 5 only. Any number, if we multiply 5 any number of times, the last digit will always be 5. Please make a note of this. Okay. Now let us look at the power cycle of 6. 6. The power cycle of 6 is 6 only, because if we raise 6 to any number, the last digit will always be 6. Let us take 7. 7 raised to the power of 1 is 7. 7 raised to the power of 2 is 49, the last digit is 9. 7 raised to the power of 3, this was explained in the previous video, this means one of the previous videos. So the power cycle of 7 is 7931. Now let us take in 8. 8 raised to the power of 1 is 8, 8 raised to the power of 2 is 64, ends with 4. 8 raised to the power of 3 is 5 and 2, which ends with 2. 8 raised to the power of 4 is 4096, which will end with 6. 8426 is the power cycle of 8. If we multiply, if you take 8 to the power of 5, it involves multiplying 8 with the last digit of 8 to the power of 4, which is 6, which will lead to 48, and hence the last digit of 8 to the power of 5 will be 8. We can look at the power cycle getting repeated. Now let us look at the power cycle of 9. The power cycle of 9. 9 raised to the power of 1 is 9. 9 raised to the power of 2 is 81. It ends with 1. And 9 comma 1 is the power cycle of 9. 9 raised to the power of 3 involves multiplying 9 with this 1, which will again result in 9. Which will again result in the last digit being 9. I hope you understand all the power cycles. Thank you.